You're looking at the brightest planet in our night sky. From your window, Venus can seem like the safest place in the solar system, a smooth white ball, soft and bright, with no visible surface and no visible weather. It isn't. It's the most hostile place a human being could ever go, so you let go. The first thing you notice is how close Venus is. It's the closest planet to Earth, closer than Mars ever gets. If any world was going to be our second home, it should have been this one. Then you hit the air, and the air is the first surprise. Venus has about 90 times more atmosphere than Earth. You're not falling into a sky, you're falling into an ocean that happens to be made of gas. The wind grabs you immediately. Up here, the entire atmosphere spins far faster than the planet beneath it. Venus itself turns so slowly that one rotation takes 243 Earth days, but the clouds lap the world in 4. Within days, you've been carried all the way around a planet without ever choosing a direction. Those clouds look like the ones over your house. They aren't. They're sulfuric acid, the stuff in a car battery, floating as tiny droplets in a sky of carbon dioxide. From orbit, it looks like weather. Up close, it's a chemical bath. And it rains here. Acid falls from those clouds in real droplets for miles, but it never reaches the ground. Around 25 miles up, it's so hot the rain boils away in midair and rises back up to make more clouds. Venus has weather that runs in a closed loop and never touches the surface. But the strangest part of the whole descent comes next. About 30 miles above the ground, you pass through a layer where the temperature feels like a kitchen and the pressure feels like sea level on Earth. For a few minutes, you're falling through the most Earth-like conditions anywhere in the solar system outside Earth itself. That matters for a reason. Ordinary air is lighter than the thick carbon dioxide around it, so a balloon filled with the stuff you breathe would float at that height like a helium balloon on Earth. A city could hang there. You could walk around inside it without a pressure suit. You'd only need a mask and something acid-proof to wear outside, but you're still falling. And below that layer, everything gets worse fast. The light goes first. The cloud deck above you is so thick that only a fraction of sunlight gets through, and what does arrive is scattered in every direction. There are no shadows. There's no bright spot where the sun should be, just a flat orange gloom in every direction, all day, for a day that lasts months. Then the heat arrives. At the surface, it's around 465 degrees, hot enough to melt lead, hotter than the inside of an oven set as high as it will go. Mercury sits much closer to the sun and is cooler than this, and there's nowhere to escape it. On Earth, you can climb a mountain, wait for night, or move toward a pole. On Venus, the temperature is almost the same everywhere, dayside and nightside, equator and poles. The atmosphere is so thick it moves heat around the planet faster than the planet can lose it. Then there's the weight of all that air. At the surface, the pressure is about 92 times what you feel right now, the same as being 3,000 feet under the ocean. A submarine built for Earth's deepest dives would be fine here, and almost nothing else would. Something odd happens on the way down because of that thickness. The air near the surface is so dense it behaves almost like water. You wouldn't slam into the ground. You'd sink toward it, slowly, the way a stone sinks through a swimming pool. Your last minute on Venus would feel strangely gentle, and then something happens that didn't happen on Jupiter or Saturn. Your boots touch ground, real ground. Solid volcanic rock, flat and dark and cracked, stretching to a close horizon in the orange haze. Venus gives you what every other giant refused, a floor, and that turns out to be the cruelest part of the whole place. There's one more thing about standing there. The air is so dense it bends light, and the horizon curves upward instead of away. You would seem to be standing at the bottom of a shallow bowl, with the ground rising gently in every direction, because now you're standing still in one place, being cooked and crushed at the same time, with nothing you can do about it. Falling forever is at least a process. This is just an ending that takes a while. We know what it looks like down there because we sent machines to stand in it. In the 1970s and 80s, a series of Soviet landers dropped through those clouds and touched down on the surface. They were built like deep sea vessels, with thick metal shells and cooling systems, and every one of them died within about 2 hours. But before they died, they sent pictures, real photographs in color, taken from the surface of Venus. Flat slabs of rock, loose gravel, a dim orange sky with no sun. Those images are the only look at that surface anyone has ever had, and each one cost an entire spacecraft. One of those landers was called Venera 13. It was built to survive about half an hour down there, which was already an optimistic guess. It lasted 2 hours and 7 minutes. It drilled into the ground and analyzed what it found. It switched on a microphone and caught the sound of wind moving through air 90 times thicker than ours, which is the first sound anyone has ever recorded on another world. Then it went quiet, and it is still sitting there. Its twin landed a few days later and did something almost funny. It ejected the lens cap covering its camera, then swung out its soil testing arm, and the arm came down directly on top of the discarded cap. The only measurement it managed on Venus was of its own lens cap. If you could survive long enough to watch a sunrise, it would come up in the west. Venus spins backward compared to almost everything else in the solar system. And it spins so slowly that a single day-night cycle takes about 117 Earth days, while a full year takes only 225. On Venus, the day is longer than the year. There is snow on Venus too, in a way. On the highest mountains, where it's very slightly cooler, something metallic condenses out of the air and settles on the peaks as a bright frost. Radar sees it as a shine on the high ground. It's probably a compound of lead or bismuth. Venus has snow-capped mountains, and the snow is metal. The ground itself has a strange history. Venus has almost no old craters, which means the surface is young. Something happened a few 100 million years ago that wiped the whole thing clean and started it over. The leading idea is that Venus has no moving plates like Earth, so heat builds underneath until the entire crust gives way at once. A planet that resets its own face. So how did it end up like this? Here's the thing that makes Venus genuinely unsettling. It was not always like this. Venus is almost exactly the same size as Earth. It's made of the same rock, formed in the same neighborhood from the same material at the same time. And there's a real possibility that for billions of years it had liquid water oceans on its surface and a sky you could have breathed near. Then it lost them. The sun slowly got brighter, as stars do. Venus was close enough that its oceans began to evaporate. Water vapor is a greenhouse gas, so more vapor meant more heat, and more heat meant more evaporation. That loop only runs one way. Eventually, the oceans were gone, the water drifted to the top of the atmosphere, and sunlight broke it apart and blew it into space. And losing the water is what sealed it. On Earth, rain pulls carbon dioxide out of the air and locks it into rock at the bottom of the sea. Without oceans, Venus had nowhere to put its carbon. So it stayed in the sky, every bit of it. That thick, crushing atmosphere is mostly the carbon Earth buried and Venus could not. So how do you survive Venus? Not on the ground. Nothing we know how to build lasts a full afternoon down there. The only honest answer is the layer you fell through on the way, 30 miles up, where the pressure is normal and the temperature is mild. A floating station up there is genuinely realistic. You wouldn't need a heavy pressure hull because the pressure outside matches the pressure inside. You wouldn't freeze. The gravity is close to Earth's, so your body would stay healthy in a way it would not on Mars. You'd only need to solve the acid, and acid is a materials problem, not a physics one. Which leads to something strange. The most Earth-like place in the solar system, outside Earth, is floating in the sky of the least Earth-like planet we have. That's the part worth sitting with. We tend to talk about Earth as if it were built for us. But Venus started with the same rock, the same size, the same distance from the same star, give or take. There was no moment where someone decided one of them would get forests and the other would get an oven. The difference came down to water and to a feedback loop that ran a little too far in one direction and couldn't be stopped. Venus is not an alien world. Venus is what happens to a world like ours when the loop tips. Every other planet we visit teaches us how strange the universe can get. Venus teaches something narrower and harder. It's the closest world to us, the most similar to us, and the one place we absolutely cannot go. Two planets started the same. Only one still has oceans. That is the entire difference, and it was never guaranteed.